Okay, Brianna, introduce yourself and your role at Open Source Ecology.
I'm Brianna Kufa. I'm currently working as a prototyper for Open Source Ecology. I've also done some of the documentation and fabrication.
Mm-hmm. And the Ironworker Machine, so that's your current project. Tell us about it.
Yeah.
What is an Ironworker?
An Ironworker is a tool you use for working with metal. It can be for steel, aluminum, copper, anything. And what it does, typically it has at least 3 stations. There's usually a punch, a shear, and then some sort of notcher. Although, at the very minimum, it has 1 or 2 of those things. Some of the cheaper ones only have like 1 of them. But there's always a shear and there's normally a punch. And so the one I'm currently working on is modeled after this Piranha. And the reason I did that is 1, because it's very simple design, and 2, because anyone you talk to is in love with the Piranha. They say that that's one of the best top-of-the-line ironworkers. So figure follow the best.
So why is an ironworker an important machine for the shop?
It's very important because you need it for automating a lot of the stuff. Not necessarily automation, but like shearing and stuff. You can shear all kinds of stuff in this versus having a bandsaw or torch cut. It saves incredible amount of time being able to shear material. Mm-hmm. Also, being able to punch saves a lot of time, and it makes things much more precise. Punching versus drilling takes much less time, and it's far less likely. You don't have to deal with breaking bits. It's just a lot faster and easier to work with. Mm-hmm. And then typically ironworkers also have some sort of a notcher, which is like a shear, but you can cut odd shapes. So the notcher on this one is like, you see it's a rectangle here, it's a 2-inch rectangle. So you can just stick something in there and shear it. So for example, if you're making a frame, you can take like a piece of angle, stick it in there like this, notch out that piece right there, and then you can bend it along this line. Mm-hmm. And you can do all of that on an ironworker. So it's very important if you're going to be fabricating a lot of stuff in general. This makes the procedure much, much faster to have an ironworker.
So what's the goal for the OSE Ironworker Machine?
The goal for the OSE Ironworker Machine is a 90-ton punch, capable of shearing 1x6 material for flat and 1/2x6 material for angle. Mm-hmm.
And the punch? How big holes?
Punch is 90 tons, which translates to about inch material, depending on where you look. Mm-hmm. At the very minimum, it'll be 7/8 an inch material.
So 1 by 6 inches for the metal shear. Mm-hmm.
Yeah, at the minimum, because this machine, I modeled it after this machine. You can see this is 2 5/8 thick. On my machine, it's 3 inches thick, and we're upscaling a lot of the other stuff so that way it has more force available. But this machine can do 1x6. It's not recommended. It says the capacity is 1x4, but we've done 1x6 on this. So I'm guaranteeing 1x6 with my machine, and then possibly more. But the thing is, I don't understand all of the forces necessary with shearing. I've been researching it for months. Nobody can really seem to tell me. So I'm playing it really safe with the estimate. Mm-hmm. Because as you're shearing, there's a bending moment in this. So the metal's pushing up here, and it's wanting to bend this whole thing upwards. And it's also pushing it out like this because it doesn't want to be sheared. So it's acting like a pair of scissors when you try to cut something too big. It wants to open up. And there's just all kinds of stuff involved that is really hard to figure out without proper computers and programs. So at the time being, we're just guaranteeing 1x6.
Mm-hmm. So what's the latest status on an overall ironworker?
I'm working on it. I'm in fabrication mode right now, getting a bunch of the pieces together, probably about halfway through. Mm-hmm. I'm dealing with the heavier stuff right now. I'm still waiting on getting these big arms in, and then a lot of the punching elements and stuff, but it's coming along.
Mm-hmm. When do you expect to be finished?
Within 4 weeks.
Okay.
Hopefully like 3, but the way things are going, it's like you never know how long it's going to take to do something when it's your first time.
Yeah. So as an open source project, what are ways people can get involved?
Well, right now what I need for this project are people that are doing CAD work, because I've got a design pretty much done. There's a few things I'm working on. There's other people that are helping me to do some of the calculations. I have someone helping me work on the stripper for the punch, make sure everything's thick enough. But yeah, right now it's pretty much just CAD, because I need this whole machine CAD'd out. But I want to have it CAD'd as I go, because I'm finding, kind of the little things that are going to change and not change. And there's no sense in doing it off my model now, because it's just the pieces that I finish are going to work or not work. And I need to make sure the ones that I do are what's in the CAD. Mm-hmm.
Is any CAE analysis useful? Engineering analysis?
It would be useful, but we couldn't find anyone to do it. especially if we could analyze the shear and see what the capacity really is.
Mm-hmm.
And also the stripper assembly and stuff for the punch. That's going to be really useful because it's stuff where if it breaks, it's not a big deal because I made it so you can take anything that breaks off of the machine. It would just be a pain to have to refabricate that, and we want to do it right the first time.
Mm-hmm. Okay. Any other comments?
It's a lot harder to build one of these than it looks.
Oh, yeah?
Yeah.
What are some of the what challenges have you run into in the build so far?
Probably the hardest thing was figuring out how to make the big holes. We've got, in my machine, I'm not sure what they are in this machine. I think it's a little smaller. We're using 2.5-inch thick pins. And this point,
Pivot points.
Huh?
Pivot points.
Yeah, for the pivot points. And we're using quarter wall bushing, so it translates to 3-inch holes. And I don't know, I hadn't considered how difficult it would be in the beginning. I figured I could just drill the holes or torch them or something. But torching material that thick is pretty challenging. It is doable. But then you can't torch it exactly. So after you torch it, you need to machine it to the exact diameter so you can fit the bushing in perfectly. And it's crucial that those bushings be in perfectly because there's going to be, I mean, at this point, there's going to be up to 117 tons of force on this point. So those bushings got to be in there damn good or something bad's going to happen. I don't know what, but so I'm making sure to do everything very exact. Like, for example, on the prior Ironworker model, what we'd done, or what Martin had done, was torch away and weld the bushings in. While that is doable, it's likely that in time it's going to stretch with all that force, no matter what kind of bushings you use. If the steel around it isn't perfectly conformed to the bushing, it's likely to stretch it out.
Yeah.
And so I'm doing everything I can to ensure that does not happen. I got my bushings hardened. They're made from chromoly steel, which is really high-grade steel that can be hardened. So they're really hard right now, and they're going in there. But I also left one out so that we can see if the hardening is really necessary for this.
You didn't harden one?
I didn't harden one, and I'm leaving that. It's going to be in one of these arms, so it's perfectly visible. So if something goes wrong, you can get it out and put a different bushing in there.
Mm-hmm. So just press fit, just loosely?
Yeah, it's press fit. If you need, you could get it out with like a press, but it's unlikely that that'll happen.
Yeah. How did you end up doing the holes?
I heated the metal around where they were going with a torch, and I put the bushings in dry ice so it shrunk them, made them really, really cold and shrunk them a little bit. And the hole I machined to about 3/1000 undersize. So the outer diameter of the bushings was 3.008 about. I did 3.003 to 3.005 for the hole diameter. That way, when you freeze it, it shrinks enough that it'll go in there. But when all the temperatures equalize, it's going to be a really tight fit that you're going to have a hard time to get out.
Okay. Well, as far as the hole itself, how would you get that?
I use our jig bore machine. You can also do it using a boring tool in a mill, which is basically it's an attachment that spins, and then it's got an Allen that you stick your Allen wrench into, and you can adjust it by the thousandth for controlling where the tool goes. So that way you can get relatively precise holes.
Mm-hmm. So that's a big machine that's not everyone's going to have. So if someone would replicate it within a typical shop, that would be a boring attachment to a mill?
Yeah, boring attachment to a mill.
Mm-hmm. All right. Yeah, excellent. So we'll get a little bit other tutorials here. Thanks a lot, Brianna.